grade 12. In this video, I'm looking at worksheet number 2. And in this worksheet, you're asked to identify the oxidizing agent, reducing agent, substance that's oxidized and reduced, and write balanced half reactions. So I'm taking this question here, which is number 6 on the sheet, as an example. So this equation is already balanced. So what we want to do to determine who's been oxidized and who's been reduced, and then the oxidizing and reducing agents, we have to assign oxidation numbers to all the substances. So starting over here, chlorate has a charge of -1. It's on your valence table. That makes potassium +1. Now we have to do the individual elements. 3 times -2 is -6. To make the chlorate anion have a charge of -1, that would mean chlorine has to be +5. +5, -6 is -1. Chloride ion here is -1, making potassium +1. Oxygen, neutral, diatomic. So as you can see, chlorine goes from +5 to -1. So because its oxidation number is decreasing, it's becoming more negative, it's gaining electrons. So we call that GER. Gain of electrons is reduction. And oxygen, on the other hand, is -2, and it's becoming more positive. It's going up the number line. It's going from -2 to 0 each oxygen. So it's losing electrons. So that's the LEO. Loss of electrons is oxidation. So the substance that's reduced ends up gaining electrons. And so in gaining, it means it has to acquire those electrons from another substance. So it's forcing the other substance to lose its electrons so that it's able to gain them. So it's referred to, the substance that is reduced or experiences a reduction is always the oxidizing agent, because it causes oxidation. In picking up electrons, it's forcing something to lose. Oxygen here, on the other hand, is the reducing agent. Because it loses, it's causing something to be reduced to gain those electrons. So that's the terminology. Identify your GER, it's the oxidizing agent. The loss of electrons, the LEO, is the reducing agent. And this, by the way, it's a little acronym for remembering. LEO, the lion, says GER, the two of them. Okay, so as far as half reactions go, actually really quite simple. What we want to do is just pull out the elements that are oxidized or reduced. Now, this is not a true half reaction because chlorine is obviously tied to oxygen, but we're going to cheat a little bit and just take the element. And we're not worrying too much about the way the reaction is balanced. I just want to make sure the individual half reaction is balanced, and that's good enough. So we're going to take chlorine, and we're going to write its oxidation state of +5 at the top, and we're going to write Cl- here. So I'm ignoring the coefficients. I'm just going to make sure that the atoms here are balanced, so there's 1 and there's 1. The charge, notice, is not balanced, and the reaction is not really balanced unless the charge is also balanced. So to do that, we need to add electrons. And we always add electrons to the more positive side, because you want to make the left side, right side charge balanced. So if we add 6 electrons to this side, -6 and +5 is -1. The charge now balances. And we've actually written a reduction half reaction. We're showing that each chlorine is capturing 6 electrons to become chloride ion. Now, oxidation, I'm going to pull out an oxygen. Don't worry about that 3 there, because the oxygen is not bonded to itself, it's bonded to the chlorine there. And we're cheating a little bit by removing it from that polyatomic, but it'll still work. Now, you must put oxygen as O2 there because it is bonded to itself. So with diatomics, you want to keep them together. So oxygen has a charge of -2 here, and right off the bat I see that the atoms are not balanced, so I'm going to put a 2 there. And I'm not worried about the fact that there's actually 6 oxygens. We could, if we want, multiply our whole equation by 3 to fix that, but I'm not going to worry about it. So I see that the charge is also now not balanced, -4 on this side, neutral on that side. So it means I have to add 4 electrons. Electrons are negatively charged. We want to make this side negative, so I'm going to put it on this side, 4 electrons. So now the charge is balanced, -4, -4. The atoms are balanced. I have a balanced half reaction showing oxidation because the electrons are being lost. So when they're lost, they're on the product side. When they're gained, they're on the reactant. So now we can go further and balance the electrons lost and gained, but we don't need to do that. I'm just illustrating what a half reaction looks like, a simple half reaction. I should mention before, by the way, when I was asking about the oxidizing agent and reducing agent, you really should list the whole substance. In this case, it's a bit strange because the same substance is oxidized and reduced because it contains the oxidized and reduced elements. So you saw what I did on my sheet. If you look at the answers to this question, I wrote the substance twice, but then in brackets I specified which specific element would actually be the one being oxidized or reduced. So for example, here, the Cl was reduced, so it would be the oxidizing agent, for instance. So you can do it that way. List the whole substance and then the specific element besides is a good idea, especially in this case where it's the same substance. The same thing's happening to the same substance. Or sorry, different things are happening to the same substance.